Hello, we have a little helper in productive machines today. My daughter Ella is here with us. This week is the half term, so she's on holiday and she wanted to come and see what I do in productive machines. She did a tap test training just 5 minutes ago, so she was able to measure this tool. She was able to measure this tool with our tap testing software. Ella, what do you think my job is? What do I do?
I think you can cut things that are hard, but like things that are really hard, solid, that are metal.
Metal. And from metal we can produce a lot of different parts. For example, we have this part. This was produced in Belfast. And then this part was produced in 1 hour, but this part was produced faster with our solution. So people can produce these parts faster. And I know that you want me to build a robot. So this could be a part of a robot. So you can build robots faster with our software.
Yeah, this can be like inside of a robot.
Yeah, this can be inside of the robot, yeah. This could be a part, maybe a gearbox component, or it could be the arm of the robot. It could be the joints, links, so we could produce anything we want with machining.
Loads of shapes, sizes, loads.
Yeah, we can do lots of things. We have a lot of different parts here, but yeah, here we only have this one. When people produce these parts, there may be some vibration problems. These tools may break. And with our software, this is our tap testing software. People do tap testing, like you did a few minutes ago. And then we measure the properties of the machines. Then that measurement goes to our software, and our software tells the manufacturers what are the best parameters to cut parts like this. And then they can produce these parts much faster and also with higher quality. What do you think the signals are?
These signals how much the sound, because normally the sounds are there like sounds.
It looks like sound, right? But it's similar. It's measuring the acceleration. So the signal, like when I hit it, I can see the acceleration increasing, or if I hit, and I can see the force increasing. So we are measuring the force and acceleration. And then the data for force and acceleration goes through these cables and then goes to the laptop. And then in the laptop, we make some calculations. So that way we can help manufacturers. Do you have any questions for me?
Question number 1.
Question number 1, okay.
Why does this have to be connected to this?
Good question.
Why can't you just listen to the sounds from your ears?
Yeah. So we are not measuring the sound, we are measuring the acceleration. But we have another software that measures the sound as well. But again, it needs to be connected with a cable to the laptop. But there are also some other solutions where there can be communication without the cables. So if you use such a communication protocol, then we don't need any cables. Maybe that's the next product for us. We can do it without the cables. So don't you like the cables then?
Yeah, it can be more helpful with those, but you can also use it. It's more easier.
Yeah, without cables it's easier. I agree. And how did you find it? Was it easy to hit to the tool with the hammer?
It's not easy to just it's kind of heavy. It is kind of easy, but it's not kind of easy at the same time as well.
Yeah, it's not very easy, but after some training, maybe after 1 hour, people can do this, because we have a very easy to use software. So there are the software which requires a lot of training, but with our software we can train engineers in half a day, Ella. So you were trained in maybe 5 minutes, I think.
Probably.
Yeah, probably you learned it in 5 minutes. Okay, thank you for visiting Productive Machines office today. Do you want to come again in the future? Maybe we can do some other things.
I don't know.
We can look to other software like SenseNC.
What's that?
SenseNC is another software. There is a screenshot there. It's running inside CAM software. I'm sure you haven't seen any CAM software before. So
What's that?
yeah, CAM software is helping people program the toolpaths in the computer environment.
Why do you use those?
We use those for machines. So this could be part of an aeroplane or a car. It could be a part of a robot.
But which part should it be? Like, what can it be used for?
Yeah. For example, you can use this for putting your fruits in it if you want.
Yeah, but metal might mix into it, like metal bits.
Yeah, so metal bits can go into your food, so maybe that's not a great idea.
But you can just put paper in there and just put your food on top of the paper.
Yeah, yeah. If you put a paper, then you put your food on it. Or you can put, what can we do with this? So as I said, this could be a part of a robot or part of a
But which
plane,
part should it be?
Or you can put your jewelry in it.
Yeah, which part should it be though of a robot?
Yeah, this is not a part of a robot. This could be, as an example. But you can put your jewelry in it if you want to.
What else can you do with this?
You can put some flowers on it.
But it won't get any water from that because metal doesn't have any water in it.
Yeah, so you need to put some water on it as well. Some soil as well, if you want to have some soil on it.
What else can you do?
Yeah, there are a lot of possibilities. Okay, thank you very much for coming to Productive Machines today. And I'm looking forward to see you again in the future here.